Good morning or good afternoon. This lesson is the second lesson for Algebra 2. The topic we're covering in this lesson is algebraic expressions, and I will see if I can get the copy of the notes uploaded so that you guys can access these to go back and see what it is that I'm lecturing from. What we're going to do is pretty much go through some vocabulary, some example problems. I'm going to cover the entire lesson. If we were doing this in a 90-minute block, the lesson would split up so that we would do some examples and then some practice and then some more examples and some practice. But we're going to go through all of the examples and then we will take the next class period and focus on getting some practice work in. So the first thing that I wanted to cover with this topic is a definition of the word expression. Sometimes this gets confused with the definition for what we call an equation, which we actually do more with in math. The key thing you want to know about an expression is that it has no equal sign. And there are certain directions that will come with expressions that we would not necessarily use if we were dealing with an equation. So, for example, you can simplify an expression. Okay, that's what we do a lot. In fact, that's what we do most of the time, is simplify expressions. We do that by plugging in numbers. We do that by combining like terms and some other things that you're familiar with. We can evaluate an expression, and that's kind of what I was just referring to. When you plug in numbers and then find out what the expression is equal to when you plug in those numbers, that's called evaluating an expression. You can also rewrite expressions in different ways. So you can rewrite a subtraction problem as adding a negative. So you can play like little tricks with them and like rewrite them in other forms. But what you cannot do, I'll change over to a red, you cannot solve an expression. So if somebody gives you an expression and asks you to solve it, the only appropriate response is, I can't solve it. Now, sometimes this gets a little obscure because you talk about math problems and you have to solve the math problem. But when it comes to the specific directions, if you're dealing with an expression, you can simplify it, you can evaluate it, you can rewrite it, but you cannot solve an expression. So what we're going to look at next is a simple example of writing an expression and how an expression can model a real life situation. Okay, so what we have here is this situation. Your grandmother gives you $20 to buy a graphing calculator. And I'm just going to say, as an aside, $20 is enough for you to buy a graphing calculator. If you recall back to the syllabus, if you go with the Casio model and you go with a used Casio, you can find them for less than $20. You might have to hunt a little bit. So try Amazon used, try eBay, you can find them. Now, on top of this $20 that your grandmother gives you, you save $6 each week from an allowance, from whatever your parents give you. And the problem here is model this situation with an expression. And so the question might be, how much money do you have after so many weeks? So the first thing we need to do is, I guess we'll start with the $20. So you have $20 that your grandmother gives you. And then you are adding to that. And like in addition to this $20, you save $6. Now you save $6 each week. So we want to figure out, how do we represent that each week? So we would pick a variable. Often in math we use an X to represent our variable. In word problems we will often use a letter that represents whatever we're talking about in the problem. So in this case, we might use a W for the number of weeks. If you were doing this for homework and you said 20 plus 6x, there would be nothing wrong with that. You can really choose any variable you want. So how this would work, okay? At week 0, so at the very beginning, you would plug in a 0 for the W. 20, yeah. 6 times 0 is 0, and 20 plus 0 is 20. So you're starting with the $20. After 1 week goes by, you would be adding just the $6. So you have 26, and so on and so forth. So if I were to ask you, how much money do you have after, I don't know, 7 weeks? I'm making up numbers here. You would plug in a 7 for the number of weeks. So that means you've saved an additional $42 on top of that. So you now have $62. And that's how expressions work. So you have some kind of real life situation and you're able to write an expression using multiplication, addition, subtraction, and so forth to model what it is you're describing in words. Now, the next thing we're going to talk about with expressions is this idea of evaluating. I can't write and talk at the same time. It happens when I'm at the whiteboard as well. So when you're asked to evaluate something, what that means is you are going to plug in the numbers and then simplify. So when you see the word evaluate in the directions, that's what it's asking you to do. And so in this case, you would have some kind of algebraic expression and you would have known values for the variables, and you would simply substitute in those known values for those variables, and then you would simplify using your order of operations. Sounds simple, it can get really nasty. So let's take a look at a couple of examples. First example that I have of this is, I don't know if hang on, I have an angry cat. Okay. I don't know if the microphone was picking that up or not, but okay, so we have 7, and then we have in the parentheses a plus 4 plus 3b minus 8. So there's our algebraic expression, and we are told that a is equal to -4 and b is equal to +5. So if you were given this and you were simply asked to evaluate, all you would do is you would take out the variable, so take out the a, and you would plug in the -4, and you would take out the b and plug in a 5. Now, notice the structure that I'm doing this. This is something I'm really, really big on, and something that will help you tremendously in math. When I taught middle school, I was a real stickler for this. You always want to work top to bottom. If you have been working left to right for your math work, I need you to stop that right now. Work top to bottom. Every line follows from the line above it in a very clear way. So if I were to ask you, where did the 5 come from? You would be able to tell me by looking right above, I plugged in the 5 for the b because b is equal to 5. And there would be no question, it's clearly outlined. Now I changed the colors up here to even make it more noticeable. Now when you evaluate, we're going to simplify. So we want to use order of operations. Order of operations say we do parentheses first. So inside the parentheses here, I have -4 plus 4. Remember, those are additive inverses of each other, also known as opposites. And then I'm going to do a separate step here. You can actually play a little bit fast and loose with the steps. But again, everything follows top to bottom. So if I were to ask you, where did you get a 0? You would look one line above and say, I got 0 from doing -4 plus 4. All right, now we would do parentheses. Next would come multiplication. 7 times 0 is 0. 3 times 5 is 15. And then bring down the -8. Notice the technique. I'm not doing anything with that -8 at all, but I do copy it down every line until I'm ready to do something with it. And then the last step with my order of operations is I do adding and subtracting from left to right. So in this case, we do 0 plus 15 is 15, and 15 minus 8 is 7. And then where I look for your answer is in the bottom line of your work. So sometimes students will stop the problem and then they'll write the answer over here. What happens is that I often miss it when students do it. That's not where I'm looking for your answer. So I am going to look for your final answer in the very bottom line of your work. And again, note, like top to bottom. For some of you, this is second nature. Whoever you had for pre-algebra or algebra 1 made you show your work this way, and you're probably wondering why I'm making such a big deal about it. For others of you, you've done it differently, or you've done lots of steps in your head and you just don't show your work. As we move through algebra 2, the problems get harder, and we're going to introduce new operations and new procedures. So what's going to help you is if you have a good technique in doing your problems, that you have a methodical way of doing it. All right, let's look at another example. All right, now this particular example, I hope looks a little bit familiar to you. You would see this kind of format in the quadratic formula. I'll just do the quadratic formula off to the side, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. All right, you should have encountered that in Algebra 1. We're not going to do it today or right now. We do it later in this course. But hopefully it looks familiar and you can at least say, yes, I saw that at some point before. This particular example is intended to mimic some of the order of operations that you would see in the quadratic formula. So here we have, now I did say that funny. If you're listening closely, you'll notice that I did not say negative b and I did not say minus b. I said the opposite of b. And there's a story behind that, and it goes back to my 9th grade math teacher who made me memorize the quadratic formula a particular way. And there's a reason why he made us do it. But I am choosing to look at that symbol, which I could say negative, I could say minus, I could say subtract, but the other word I can use there is opposite. And there's a reason for that. It actually avoids a mistake. It's a little verbal trick that I use. So what we're going to do here is plug in the numbers. So instead of a b, I am going to put in a 3. And then this is read plus or minus. It means you're actually going to have 2 different steps with 2 different operations in there. And then I'm going to take out the a and substitute in the 25. And then the way I would read this out loud is all over 2. And what that indicates is that the fraction bar is going under everything. If you don't say it out loud or you don't write it correctly, so you make your fraction bar shorter, it actually changes your order of operations. So this particular problem doesn't fit our PEMDAS because you're like parentheses. Well, there's no parentheses, but there is something we need to do first. When you're dealing with the P in your order of operations, instead of thinking of it exclusively as parentheses, I want you to think of it as any grouping symbol. And the most common grouping symbol is parentheses, but there are lots of other grouping symbols. And in this particular example, we actually have 2 other grouping symbols. One of the grouping symbols is the fraction bar. And that's why the length of the fraction bar is important. That fraction bar is grouping the numerator together, just visually by making it a long fraction bar. If you make it a short fraction bar, then it will not group the numerator together, that whole thing. The other grouping symbol that we have is this square root. So if you had some other stuff going on in here, you would want to do this first. And when you're dealing with grouping symbols, you always start with the innermost grouping symbol and work your way out. So because I have a grouping symbol here and a grouping symbol here, this group is inside this group, and I'm going to start by taking the square root. So we're going to have -3 plus or minus the square root of 25 is 5, and that is all over 2. Whoops, that did not activate the eraser there. There we go. All right, now we run into the problem where we have this weird symbol, this like plus or minus, and hopefully you can add and hopefully you can subtract, but none of us are that good that we can do them both at the same time. We can either add the numbers or we can subtract the numbers, but we have to commit to one or the other. So what we have to do at this point is we actually need to split the problem in half. One of the problems becomes an adding problem, and the other problem will be a subtraction problem. So you actually need to split the problem in half. And so one of the times you're going to add and the other time you're going to subtract. Now this is where it is so important that you have the fraction bar the right length. And if I have time, and I think I do, I'll show you what happens on your calculator and stuff if you don't do it right. So now we look at the second grouping symbol. Remember, the fraction bar acts like a grouping symbol. And so in this left-hand problem, I'm going to do -3 plus 5. I always use football as an analogy, and we typically do this during football season. So if you lose 3 yards and then gain 5, so the negative means you're going backwards and the positive means you're going forward. So first down, you lose 3 yards, and the second down, you gain 5, which means that overall you have gained 2, and then 2 divided by 2 is 1. Over here, you lose 3 yards and then you lose another 5, which means you have lost 8. And -8 divided by 2 is -4. So this actually has two answers to it, 1 and -4. And when you're doing the quadratic formula, you do have to present both answers. You can't just pick the one you like better and just give that one. All right, so there's some order of operations stuff. Now, a quick little word about the fraction bar. Okay, let's talk some vocab. Back, this is like years ago, I taught Algebra 1, and I was using this vocabulary, terms, like terms, coefficient, and my students weren't understanding what I was saying, and then it dawned on me that it was a vocab issue. So I know vocab is very dry, but if you don't know what the words mean, then I can explain stuff over and over and over again, but it's not going to help you. All right, so let's take a look at this expression. We have 3x squared plus 5x squared minus 2x plus 3. So when I'm talking about this particular expression, there are certain words I'm going to use to refer to parts of it. First key word that you need to know is the word terms. Now, you can think of like a term. We're in first term right now. The terms that you memorize for Spanish class, like what does that word mean in math class? So in math class, when we refer to terms, what we mean are expressions that are added or subtracted. And I'll finish writing that in there. Okay? Added or subtracted. So looking at this particular algebraic expression has 4 terms in it. 3x squared is a term. 5x squared is a term. I know that because they are being added together. 5x squared is a term. 2x is a term, and I know that because they are being subtracted. And 2x and 3 are terms. So the terms are the 3x squared, 5x squared, 2x, and 3. Some people might say -2x, and that has to do with the fact that subtracting means to add the opposite, which I'm going to get to in a little bit. Second vocab is like terms. Like terms are terms that have the same variable part. And the variable, of course, is the letter. Okay, so when we refer to like terms, we are referring to terms that have the same variable. In this, we have the 3x squared and the 5x squared. Those are considered like terms because they have the same variable part. The 2x is not considered the same, and that's because of the squared. This has x squared, which is x times another x, and this one only has the one x. So you can't say, oh, well, they both have x's, they're like. No, they have to exactly match in terms of x's, y's, z's, w's, whatever you got, and how many of them you have. Next term, vocab word, and this was one that came up a couple years ago in an Algebra 2 class, is the word coefficient. The coefficient is the number multiplying the variable. Sometimes you'll hear people say it is the number in front of the variable. But let's be really clear with this. Okay, I'm going to look at the 2x here. This is multiplication right there. That is 2 times x. And so when we're talking about the coefficient, the 2 is the coefficient. In these terms, 3 is a coefficient, 5 is a coefficient, 2 is a coefficient. You could also hear people say -2, okay? That, again, ties back into the definition of subtraction. And that was one that I assumed people knew, and then I realized I had a lot of students that didn't know what it was. So it's kind of like a scary, complicated word for the number multiplying the variables. And then the last one is the constant, and a constant is a term with no variable. And so in this particular example, the 3 is the constant. Hopefully that vocab is familiar to you. It's not brand new vocab. But if you had some confusion about like using the word terms versus factors, that's going to come up later. Or somebody has tossed out the word coefficient for years and you just weren't sure what it meant, that we are all on the same page with that. All right, one more small concept and then we're done with this lesson. All right, I love this stuff, and this is going to come up all year long. I am going to refer back to this lesson, and I'm going to say, remember like the first week of school when I told you there's no such thing as subtraction? And it's traumatizing because you've probably thought that subtraction was a thing ever since first grade. But your first grade teacher lied to you. There's no such thing as subtraction. So let me explain. The definition of subtraction is simply this. It means to add, oh good grief, add the opposite. So to understand this definition, we need to understand the definition of the word opposite, which we covered last class. So subtraction just means adding the opposite. Now, the reason your first grade teacher didn't teach it to you that way is because that involves understanding what a negative number is. And when you're in first grade, you don't know what a negative number is. It's a lot easier to explain subtraction as takeaways. So I have 7 take away 4. But here's what we mean, because we're not in first grade anymore. If you have A minus B, that can be rewritten as A plus the opposite of B, or negative B. In middle school, this is sometimes done as like, you do subtraction as like keep, change, and stuff. This was kind of a little bit backwards, but that's what subtraction is. It just means you're adding the opposite of whatever number you were subtracting. So for instance, if you had 7 minus 4, or 7 take away 4, that is the same thing as 7 plus negative 4. So if we go back to what I was doing over here, and I said, well, some people will say the coefficient is 2, other people will say negative 2. The reason that they'll say negative 2 is because in their heads, they'll think of it as plus a negative 2. And so they'll just process it that way instead. When I was in Algebra 1, my Algebra 1 teacher did not let us write subtraction the entire year. Every single time we had subtraction, he made us rewrite it as adding a negative. My mom is a math teacher, and you'll probably hear me talk a lot about her. She watches all these videos too, because she's nerdy like me. But she thought that was really stupid, because it really seems like an extra step. But it really helped me to understand how subtraction worked, and it avoided a lot of other mistakes. So no such thing as subtraction. Subtraction just means adding an opposite. Now, you can do the same thing with division. There's no such thing as division. So what on earth are we doing when we divide? We are actually multiplying by the reciprocal, which is why those definitions in that last lesson are important, that you know what an opposite is and you know what a reciprocal is. The reciprocal is when you flip over the fraction, also called the multiplicative inverse. So for example, if you have A divided by B, that could be written as A times the reciprocal of B. And you would simply flip it over. So for example, 4 divided by 2 is equal to 4 times 1/2. If you don't believe me, pause the video and grab your calculator and put in 4 divided by 2, and then, hopefully you get 2, and then do 4 times 1/2 and see what you get. It will come out the same. Now what this does, you're probably like wondering, why on earth is this an important thing? This allows us to rewrite problems. So it goes back to the idea of algebraic expressions and different ways that you can rewrite them. Sometimes it's better to have that fraction there and to think of the reciprocal. Other times you'd rather have a division symbol. Sometimes we like the subtraction, but I'll show you where that becomes an issue. If you had something like this and you had to distribute, so we talked about the distributive property, you are not distributing a 4. If you distribute a 4 and you say 7 minus 4x plus 8, you will get it wrong. What you are distributing there is a -4, because that 7 minus 4 is really 7 plus -4. So you'll have 7 minus 4x minus 8. We will do more of that in an upcoming lesson where we go over solving linear equations, but that's why we want to be able to think of our subtraction in different ways and why we bother knowing ways of rewriting things. Last 2 concepts here, multiplication by 0. If I say it once, I'll say it a bajillion times. 0 is my favorite number. So Miss Taylor Trivia, ask anybody who's had me before. If you have a friend that had me before, like, what's Miss Taylor's favorite number? 0. And this is kind of the reason why. If I take any number, hopefully I can write it better than that. That was terrible. Any number, and I multiply that number by 0, I will get 0, which makes doing math with 0 fantastic. Adding 0 is also really great because it leaves it alone. It's that additive identity. So if you have a whole bunch of garbage, okay, so I got this bunch of garbage times 0. Answer is 0. It's fantastic. It's a wonderful number. Don't forget that. It's an important concept as we're going to use it when we factor. The last thing is the opposite of an opposite. So if you think of like opposites in language, like the opposite of tall is short and the opposite of short is tall. So if you take the opposite of an opposite, you end up back where you started. This negative symbol I mentioned earlier can also be read as the opposite. So if you have the opposite of an opposite, you are right back where you started. So sometimes you'll hear people say stuff like, well, when you subtract a negative, it's the same as adding. That's why. If I have 7 minus -4, okay, you say, well, subtracting a negative is the same as adding. But why? Because if you're just memorizing a rule, that is not helpful. Remember, the definition of subtraction is to add the opposite. So I'm going to take this right here and I'm going to add the opposite. Well, the opposite of -4 is +4, and that's where the 7 plus 4 comes from, and why subtracting a negative is the same as adding. So we have this idea of the opposite brings you back to where you started. All right, so that is a wrap on the second lesson. There'll be some kind of homework assignment. I'm trying to do this lesson quite a ways in advance, which is why there's no date on it. And there'll be some homework assignment. And then what we'll do next class is we will go over the homework. I want to open that up for as many questions as possible. And then we'll just devote some of the class time to simply getting more practice with these concepts. If it seems really easy to you and you're like, this was Algebra 2 and I feel like I'm back in Algebra 1, just be thankful for it, because it does get a lot harder, and it's good to start off really grounding ourselves in the stuff that we've had before, especially if you struggled in Algebra 1 or you've forgotten a lot of it. If you are losing the train of this already, I am going to have some tutoring sessions. As of this recording, I'm kicked out of all my teams, so I don't know what's going to happen. But we will set up some tutoring sessions, and I want you to tell me if you're having a hard time. Okay, so there's a wrap on that lesson. Hope it was a good one.